DD-based case study on compounding in turbines. So before going to our DD-based case study, let's have some introduction about yourself.
Hi, myself Hamsavarthan, studying mechanical in this idea with my friends Navanithan, Manish, Ashwan, Moonsing and Maheshwaran.
Okay, now let's go for the DD-based case study with the introduction.
Hello everyone. So today we are going to see very interesting topic of thermal power plants. So for first of all we are starting. So in this room where we are getting the energy, this lights and fan are runs on energy which are get from thermal power plants and hydraulic power plants, wind power plants and solar power plants. So these are energy we are getting from nature and converting into many form of energy. So further we will continue now.
So what Moonsing is telling is you have just told about the thermal power plant. You are dealing with the energy which you are getting here. Okay. Now
I'm going to talk about the design thinking 5 stages like empathy, define, ideate, prototype and testing, and further we can bring this transform.
you are going to approach this DD-based case study with the 5 stages of empathy. Okay, let's continue.
Yes, as Navanithan told, we are going to approach this problem statement as design thinking approach. In this, we are taking that working of the turbine, thermal power plant, in which it consists of various components like Maheshwaran will say.
The components of turbine, boiler, nozzle and condenser and feed pump.
Okay, you are telling the components are boiler, nozzles, turbines, and then condenser, and then feed water.
Now we see what is empathy.
Yes, the first layer will say the overall working of this thermal power plant. First, the feed water pump will give the water. It will be traveling through that. Before the turbine will reach that nozzle, the nozzle is to reduce the pressure and increase the pressure velocity. In turbine, it will convert as steam. Then, with the same velocity, it will be go to the condenser. You see, this high velocity steam reaches the turbine. At this condition, the condenser will lead to something reduced efficiency and performance. So that we are going to say that empathy part of this.
Okay, you are telling that what Amsavan is telling that. So steam is formed in the boiler. So that steam is used to run the turbine. So here, normally, this steam can be made to run the turbine. But to have more efficiency, we are using nozzles to increase the velocity. So when the turbines are rotating with high velocity, so heat energy is converted into mechanical energy. Okay. Very good. So now what is the purpose of condenser? What he was telling is with the same speed, if the steam approaches the condenser gets affected. So now let's continue.
So for this one we are going to introduce 3 types of compounding.
That is, you are coming with the what's defining or mediate, what is the stage of
this is the defining stage. So we are introducing 3 types of compounding, which are pressure compounding, velocity compounding, and third one is velocity and pressure compounding.
Now you can also give your how you are going to implement, what is your idea, how you are going to test and
So using a pressure component can reduce the pressure, and using a velocity component you can reduce the velocity, and the pressure velocity component can reduce the both.
Save the
we are telling that we can reduce the. So how this pressure is reduced by what? How the method is? What is the method? What we are going to implement?
Adding the extra nozzle and extra base inside the extra.
It will reduce the pressure.
No. Let us first discuss with the velocity compounding. Okay, and then pressure compounding. First, if you take the pressure compounding, you want to reduce the pressure. So what we have to do?
We need to add more nozzles.
We are going to add more nozzles and then we are going to test it. So in nozzle, what happens? What is the main principle? Is
Reduce the
pressure. So if we are using number the pressure decreases. So this is one method you are going to deal with the pressure compounding. What about the velocity compounding? How you are going to reduce the velocity?
More turbine rates, more turbine rates, so that the velocity will be decreased, pressure will be decreased.
Oh yeah, for second stage, if you want to decrease the velocity, you are using more number of moving blades,
in the turbines.
but you are not using the nozzles.
No.
You are not using nozzles.
Used to reduce the velocity.
Or when you are using the more number of blades, as the steam is expanding in the moving blades, so its velocity gradually reduced. So what according to the required velocity, we can use the more number of moving blades. So what about the pressure velocity?
We use both nozzles and the blades. So that both pressure velocity will be reduced and the condenser will not be.
This method easily can control the.
So when you are doing like this, condenser can be safeguarded from the high velocity of the steam. So the failure of the condenser is avoided. Is to reduce the steam from the turbine pressure to the condenser pressure.
Control the air pollution.
So to control the pollutions, you want to alternate the steam production method. That is, you want to implement solar. Okay. So thank you for your question. Thank you.